Compute the quantities below right does not exist if the limit does not exist or the value is undefined. F at 0. Let's do that one first. F at 0. 0 looks like it falls on this piece of my piecewise function, so we're going to use the
appreciate
negative
the
12.
respect, but don't forget, time is a dimension, and I'm the one who bends it. Keep up or get left behind.
You really put a lot of work into stream. It's pretty awesome for viewers. Oh, I appreciate you saying that, Fem. Thank you very much. Yeah, it does. Sometimes, when I can't fall asleep at night until like 2 in the morning, I'm just like, you know what I'm going to do? I'm just going to play around with Streamer.bot and make things kind of fun. So we were talking about f at 0, so that means we can use the green highlighted area. We can sub 0 into that, and we should get negative 12 over 6, which is negative 2. So what about the limit as x approaches 0 from the left? What piece are we going to use here? So for values slightly smaller than 0, I think we're going to use the same thing. So we have negative 12 over x plus 6. And this is a continuous function, so we should be able to just put 0 in, and we get negative 2 like we did before. So that should be fine. And then finally, for values slightly bigger than 0, we're going to use this piece, which is 14 over x minus 7. Oh, interesting. If we do that direct substitution, because this function is theoretically continuous at 0, so we have 0, take 7, so this is negative 2 again. Oh, interesting. So this piecewise function is continuous at 0. Interesting. And I guess if we want to finish this up, the above 3 quantities are the same. All defined and equal is what I would pick. We know that f is continuous. So that's how we kind of finish up this. And in our case, we don't really have any places of discontinuity here. Well, I guess maybe at like negative 6 and positive 7, we might be in a little bit of a... So like maybe negative 6 and 7 might be some tricky parts, because I can see that the denominators here might make this have maybe an asymptote or something like that. So maybe at 6 and 7, we're going to run into some issues for this particular function. So the idea here is really we just want to look at the limit of what I would call kind of the dominating terms is usually what I call it. So if I look at the numerator, I look at the highest power of x in the numerator. In this case, it's 5x. I look at the highest power of x in the denominator as well. In this case, it's minus 4x. So in the long run, this 5 and 8 aren't really going to matter for really, really big values of x. My limit's going to act kind of like this. So it means my limit's going to be negative 5 over 4 when I cancel out these x's. So it's the 5 and the 4 here that kind of dominate this limit for really big values of x. Okay, let's take a look at this limit. This is going to be the limit as x approaches infinity. We're going to take the highest power of x in the numerator and the highest power of x in the denominator. And since the higher power of x now is in the denominator, so this is my dominating term out of both of these, right? So in other words, I could, I guess, cancel out an x, and then 8 divided by something really, really big is going to tend towards 0. What's this going to be? This is going to be 2/6, isn't it? So can't we just grab the... So we look at the numerator, and we look at the highest power of x in the numerator. It's the square root. Oh, no, it's root 2. So we can take that highest power. So we can do a dominant terms analysis. We can take our 2x squared under the root. So that's going to be our dominating piece in the numerator. And in the denominator, our dominating piece is going to be 6x. So I think I'm okay doing this. And I know that x is going to be positive, so the square root of x squared is just going to be x. So this should be fine. We should get root 2 times x over 6x. So x's cancel, and we're going to be left with root 2 over 6. Root 2 over 6, I think. Let's take the largest t in the numerator. The largest t in the denominator would be t squared. Since t is positive, we know that the square root of t squared is just t. So now we can get rid of those, and we have a limit of -3 should do the trick here. Oh, wait a second. So let's observe a couple things. This is the exponential function, e to the x. So the limit, as x gets really big, of the exponential function is pretty big. However, the limit, as x gets really big and negative of e to the x, actually tends towards 0, doesn't it? So if we look at this one up here, and we're trying to figure out what's happening as e to the x gets really big, well, that means we're going to get something kind of like 8 over infinity, because our denominator is going to get huge. So this is going to tend towards 0, I think, right? Yeah, 8 over something really big. And then what happens down here? So we can think about this as 8 over, this is going to tend towards 0. So this is going to tend towards -8/9. -8 over 9?